Hello everyone, this is Mr. Underkoffler, and this is part 2 of the guided notes called Composite Figures. Going to the third page where it is called Area of the Shaded Region. So make sure you are turned to that page, and let's go ahead and begin. Area of the Shaded Region. To find the area of a shaded region, you're going to find the area of the entire figure, and then subtract by the area of the non-shaded section. And sometimes you're going to have more than one non-shaded section, which is why I put parentheses S here. All right, so directions. Find the area of the shaded region, round to the nearest tenth if necessary. Okay, so this almost looks like a square. But if you look, the length going at the top is 40 feet, and the width going on the side is not 40 feet. It's close. It's 38 feet. So that's why this is not a square. This is a rectangle. So the total shape is a rectangle, but there is a section that is not shaded. And you can see it's right here. It's kind of like I took a bite out of the rectangle. And this is not a full circle. This is not even a semicircle. This is a quarter circle. So I've already labeled this for you. We got a rectangle and we got a quarter circle. What we're going to do is we're going to find the area of the total shape, which is the rectangle. And we will get that by using the rectangle's area formula. You can go ahead and start writing this down. And then we're going to eventually subtract away the area for the little piece that's not shaded, and that is the quarter circle. And that would be pi r squared, but not just pi r squared. You're going to have to multiply by 1/4 because it is 1/4 of a full circle. Okay. Let's go ahead and do formula substitute solve and formula substitute solve, and then we'll eventually subtract. The length and the width of the rectangle you can see is 40 feet and 38 feet. Get your calculator ready. 40 times 38, boom, gives you 1,520 square feet. All right, for the quarter circle, what is the radius? This one is not as obvious. Let me get out my pen here. If it was a full circle, that is a really bad full circle. Come on, Mr. Underkoffler, you can do better than that. If it was a full circle, then you would see the radius is actually from the center to either the left or right or going up edge. That is 15 feet. So I know that was not super obvious, but for a quarter circle, this is actually considered the center, and therefore these measurements going up and left, they are the radius. Okay, so there we go. If you want to make the quarter become 0.25, feel free to do so. Easier to punch into your calculator. 15 to the second power is 225. Take that times 0.25 and you will get 56.25. Bring down the pi. That's right. Like I mentioned in part 1 of the video, I would not get the crazy long decimal that goes on forever using your pi key in your calculator. No, I wouldn't do that yet. I would keep this in terms of pi, where you took 15 to the second power, multiplied by 0.25, got that result, and then brought down the pi and put it next to it. Then, as I mentioned earlier, we are going to have to not add. This is not two shapes together making a composite figure. This is a shape that was taken out of the rectangle. That's why we're going to have to subtract away the quarter circle from the rectangle. So, fill in the blank. Now it's time for us to subtract. Take the total area, which was the 1520, subtract away the non-shaded area, which is 56.25, times pi. Go ahead and enter this into your calculator. Don't forget to hit times pi. And you will get 1,343.3 square feet if you round to the nearest tenth. Now, there is one type of possible exception when it comes to finding area of the shaded region. Follow along with me. If the shaded region is a shape whose area you know how to find, then you can do the work by simply just using that shape's area formula. Okay, what do I mean by that? Well, once again, we see we have the rectangle that almost looks like a square. It's the same rectangle I had in problem number 5, 40 feet across, 30 feet wide, 38 feet wide. But this time, instead of taking out a semicircle, this time I took out a triangle. But I want you to look at what shape this shaded region makes. It is a four-sided shape where the top and bottom are parallel, but the left and right are not parallel. So it's not a parallelogram. This is write it down in the blank, a trapezoid. And therefore, I don't have to do the work that I did on number 5. I don't have to find the area of the rectangle, find the area of the triangle, and then subtract them away. I can work smarter, not harder. I can just find the area of the trapezoid, because this shaded region is a trapezoid. I wish I could have done that on number 5. I wish there was a name for a rectangle that had a little bite taken out of it, but there is no name for that, and therefore there's no formula for that. That's why I had to do this the longer way. Full area, non-shaded region area, and then subtract. But number 6, we can just use the area formula of a trapezoid. Okay. Can you figure out what base 1 and base 2 are? They are always supposed to be the parallel sides. Well, we know base 1 is 40. That's pretty easy to see. But what about down here? Can you use the skills that I taught you the previous day of part 1 of the guided notes? Hit pause, figure out what base 2 is, and then hit play once you're ready to see if you got it right. Okay, did you already figure out base 2 down here? If you take the total length left and right of 40 minus the left and right length here of 17, then that will give you the left and right length that we need remaining for base 2. 40 minus 17, boom, is going to give you 23 feet. And that is base 2. Hopefully you figured out the height, touches the right angles for the bases, so that would have been the 38 feet. This is your substitution step. If you want to keep 1/2 as 1/2, you may. I like to keep it 0.5. It's easier to punch into my calculator. All right. You can enter this whole thing into your calculator if you know how to use your parentheses keys. If you're not comfortable using your parentheses keys and you would rather take 40 plus 23 first and get 63 and then multiply 63 times 38 and 1/2, that is fine with me. The answer you should get is 1,197. Again, everything was in feet, so the area is square feet. Okay, now that we've talked about the normal way of getting area of the shaded region, which was number 5, and then the one possible exception that doesn't happen often, but we practiced it on number 6, now that we've done those two problems together, let's have you try some on your own. We got number 7, which you can hopefully see is a semicircle with a triangle cut out of it, basically. And you'll do that on your own. And I would like for you to try number 8 as well, which is on the top of the next page. Has a little bit of a story to it, but you can see it's still an area of the shaded region type of problem. Okay, so hit pause on the video, do 7 and 8, and then hit play when you're ready to see how you did. Okay, did you already do 7 and 8? If not, you better hit pause now, because it's now time for me to go over this. Okay, with this semicircle, we are never ever given the radius. And we kind of need the radius because the radius goes from the center to an edge. It's the height of the triangle. So that's the first thing I need you to realize. For the semicircle and the triangle, the radius will be the height of the triangle. Now, you don't have to write that down, but that's the first big idea you need to figure out. Now, how am I going to get that radius? Well, if I can get the diameter and divide it by 2, I will get the radius. And I am given the diameter. Right here it is. So if I take 28 and divide it by 2, that is going to give me my radius, and the radius will be the height of the triangle. Cool. That means I pretty much have everything I need. All right, area formula of a semicircle. Don't just do pi times radius squared. I've talked about this in part 1 of this video series of composite figures. Pi r squared is the area of a full circle. This is not a full circle. This is half of a circle. So this is why I recommend multiplying pi r squared times 1/2 to get the area of a semicircle. For the area of a triangle, that one's pretty cut and dry, straight from your formula sheet, 1/2 times base times height. Okay, we know the radius. I highlighted it for you in yellow. Radius is 14, and we already said that's also going to be your height. So the height is 14. Now, what's the base of the triangle? It's not 28. 28 goes from here the whole way across to up there. That's not the full length we need for our base. We just need from here to here. Oh, that's the 21 meters. So hopefully you had 21 as your base. And here's the rest of this work. 1/2 is 0.5. 14 squared is 196. 196 times 0.5 will give you 98. Bring down the pi. That's right. I mentioned this before. Don't get the ugly decimal right away. You don't want to round it to the very end. So for now, keep this answer in terms of pi. For the triangle, you should have got 147 when you took 0.5 times 21 times 14. Okay, from here, we will subtract away, just like we did on problem number 5. Subtract the total area of the semicircle minus the area of the triangle. Don't switch that order. I know some of you are thinking 147 is bigger. It's not. This is 98 times pi. Pi is, remember, 3.1415926, yada, yada, yada. So this is going to be an answer on the left bigger than 147. Trust me, it is. All right, subtract in your calculator. You'll get 160.876. Round that to the nearest tenth. It is 160.9 because the 7 is big enough to make the 8 round up. Since everything was in meters, you need to have your area as square meters. If you messed up your work, feel free to hit pause and fix your work right now. Okay, moving on to problem number 8. I'm going to split this up as an outer circle and an inner circle. The outer circle had a radius of not just 10. 10 is the radius of the inner circle, but you need to add the distance from here to here to get the full radius of the outer circle. And that is 13.5. How do I know? Because the little walkway that goes around is 3.5 foot wide. So 3.5 plus 10 gives you a full radius for the complete circle, the outer circle, of 13.5. Notice I am not using 1/2 this time. Why? These are not semicircles. These are full circles. So no 1/2 would be used for full circles. We only multiplied 1/2 times pi r squared when it was a semicircle. Okay, where was I? So that's what you're going to do for the outer circle. The inner circle simply just had a radius of 10. All right, so 13.5 to the second power should have given you 182.25. Bring down the pi next to it. Again, don't get the crazy ugly decimal. Keep it in terms of pi. For the inner circle, 10 to the second is 100. So that's 100 pi. Again, don't make it 314 point something. No. Keep it in terms of pi. Okay, from here, subtract the outer circle, the total circle, minus the non-shaded circle on the inside. And you will get 258.39. The 9 is big enough to make the 3 round up to 0.4. And make sure you say square feet. And I should have circled that answer, and I'm not quite sure why I didn't. All right, the last part of these guided notes takes us back to composite figures. These are not area of the shaded region problems anymore. But this time we're going to throw back in scale. You might recall we did scale on the problem-solving guided notes on area and circumference. Well, here it is again. You'll recall the number on the left is the drawing measurement, sometimes the model measurement, if there's a scale model. The number on the right is the actual real-life measurement. So, problem number 9. Hassan has designed a scale drawing of a brick walkway as seen below. The scale of the drawing is 1 inch equals 8 feet. What that means is every inch on the drawing actually represents 8 feet in real life. So, spoiler alert, you're going to have to first do some conversions where you multiply, little sneak peek, where you multiply the measurements given to you on the drawing times 8, because every 1 inch is equal to 8 feet. After you do that, then you might want to go ahead and start crossing out measurements and replace them with what they actually are in actual feet. Then you can break this apart into two separate shapes and find the area of the composite figure. When you're done with part A, I would like for you to try part B as well at the bottom of the page. So hit pause right now, do part A on your own. I kind of already got you started, talking you through it. And also try part B then on your own, and then hit play when you're ready to see how you did. Okay, have you already done part A and part B? If not, you better hit pause now. So for the conversions, we take 0.5 times 8, 0.75 times 8. We don't have to do 0.5 times 8 twice. It's going to be the same thing each time. And 1.5 times 8. So 4 feet, 6 feet, 12 feet. Let's go ahead and label all these. Okay, so the 1/2 inch was 4 feet, and that would also be the 1/2 inch down here. And then what we have, the 0.75 gave us 6 feet, so I'm going to go ahead and label that. The 1.5 inches was actually 12 feet. Okay, those are the actual real life measurements. Did you split this up like so that you have a rectangle at the top and a trapezoid at the bottom? I guess you wouldn't have to do it that way. I guess some students could have made the rectangle go like this, and then you would have two different triangles. That could be a way of doing it. The total length of the rectangle would be 10 feet, and then the width across would be 4 feet. And then for the triangles, you would have to take 12 minus 4, giving you 8, which means this is 4 and this is 4. So you basically have 4 by 4 triangles. That could work if you want to do it that way, but I am not going to do it that way. Okay, so if you did it my way, trapezoid, formula, substitute, solve. Hopefully you had 4 feet across as base 1, 12 feet across as base 2, and the height was 4, giving you an area of 32 square feet. For the little rectangle that was at the top, that's going to give you 24 square feet. Add them together and get 56 square feet. If you did it the other way, where you had the big rectangle, the area of that would have been 40 square feet, because 4 times 10 is 40. And then the two triangles, each triangle would have been 8 square feet, because 1/2 times 4 times 4 would have given you 8. And then 8 times 2 is 16, and 16 plus 40 would have still given you the exact same answer that I got of 56 square feet. If you need to rewind the video to hear me explain that again, because I don't have diagrams showing that, and I apologize about that, feel free to rewind the video if you did it in that alternate way. Finally, part B. One case of bricks costs $25 and covers 6 square feet. This is a two-part question. First part, how many cases are needed to cover the walkway with bricks? Finally, what would be the cost? Okay, do you remember what our area was? It was 56 square feet. We need to use that. We know one case of bricks covers 8 square feet. Did I say 8? I meant to say 6 square feet. So if we take the area that we got at 56 and divide it by 6, then we will find how many cases we need of bricks. And it's about 9 1/3. In fact, it's exactly 9 1/3. Point through repeating is 1/3. But can you buy 1/3 of a case of bricks? I don't think you can. I think Lowe's or Home Depot or your local hardware store would not be very happy if you tried to buy 1/3 of a case. So you're going to need to buy more than what we ended up figuring out. More than 9 1/3 cases, which means you're going to need 10 cases. And yes, that's going to give you some bricks left over. That's okay. It's better to have more than enough than not enough. And if you have to cut the bricks, then yeah, you're going to have waste left over. When you guys get older and do home improvement projects, you'll know what I mean. So having more than enough is actually very smart. Okay, what's the cost? The cost. Well, one case of bricks is $25. So 10 cases of bricks would be 10 times 25, which is $250. And that concludes the guided notes on composite figures. This was specifically on area of the shaded region for the majority of part 2 of the video. Thank you for watching. We'll see you next time.